The Nautel webinar on introducing the MVlt series of analog FM transmitters. I'm Chuck Kelly, Director of Sales here at Nautel, and my special guest is Mike Woods, Head of Development. Welcome, Mike.
Thank you. Good afternoon.
For those of you who know Mike, you may not know that he's an accomplished guitarist and always stars at the Nautel Jam. So welcome again, Mike. Glad to have you with us. He's the Head of Development in our engineering department and played a very key role in the development of the MVlt series. So here's what we're going to talk about today. The MVlt series, what we're really talking about is the expansion of the MVlt series now. Last year we had the 3.5 to 10 kilowatt versions of MVlt. Now we've expanded up through the 15 to 40 kilowatt versions, actually all the way up to 44 kilowatts in total rated power. So we're going to talk about how we got here, how the MVlt was created, what technologies came together to make this possible. We're going to talk about the optimized design. We're going to go into the detail of the MVlt series, the performance, the architecture, redundancy features. One of the things about solid-state transmitters is the incredible redundancy within these transmitters. We're going to talk about the lower cost of operation. Talk about our AUI, advanced features, and then we're going to do my favorite part of the program, which is always doing a test drive. We've actually set up a 20 kilowatt MVlt transmitter down in the test room, and we're going to walk through that live and let you see how it works and play with it. So, as always, you have the opportunity within the GoToWebinar suite of tools that you're obviously running here to ask questions, and please do ask questions, type them in, and we will be very glad to deal with those questions as we can, and at the end of it. And so we will go and check all the questions. If by chance we don't get to your question by the end of the webinar, all those questions that you have typed in will be saved for us in a file, and we will read that file at the end of the webinar, and we will make sure you get answers to your questions. So how did we get to this point with the MVlt development? It's a combination of multiple things. In 2008, Nautel introduced the Advanced User Interface, the AUI. It would be ever so simple and easy just to call the AUI an AUI, just a user interface. But it's far more than that because it's got so much it has so much depth in the transmitter. There's so many things we're monitoring in the transmitter. In larger transmitters, literally hundreds of items that we're taking samples of and we're making available through the AUI. And it also includes integrated test equipment that you won't find in most other transmitters. And this is all brought together through an internal web server. So it's a very, very powerful tool that gives you the ability to stand in front of your transmitter from anywhere with a whole rack full of test equipment and understand what's going on deep down inside the transmitter before you get into your car at midnight to go to the transmitter site and know what's wrong with it. It's also a combination of the technology that we developed in the NV series, which was the most advanced solid-state FM transmitter we'd ever developed. It included an integrated exciter, the smallest footprint, high-power solid-state FM. You know, there's 3,000, I should mention this, 3,000, John White would be very upset with me if I don't mention this. There'd be 3,000 transmitters out there utilizing the AUI. Of those, 1,200 of them are NV series. And a lot of those are very high power transmitters. Over 300 of those NV transmitters are replacing tube-type transmitters. Literally millions of dollars worth of tube-type transmitters have been replaced with the NV series. And then the other part that really is a part of the MVlt series is the VS series, our revolutionary low-power FM transmitters that included audio over IP, the Orbit inside option, push radio, and over 1,800 of those have already been sold, which is pretty cool. So let's talk about the MVlt series that we've now introduced and brought out so that it can deal with up to 44 kilowatts of power. These are the power levels of all the models, all 8 models we now have available. And we can go up right up to 44 kilowatts, and the MVlt series can do down to 150 watts. We did win a Cool Stuff award for the MVlt series back in 2012 from Radio World, and we're very proud of that, actually. So here's the things that are common to the MVlt series. No compromise performance. We're talking about a fully digital exciter which is more of a computer than it is an exciter. When I think of an exciter, I think of lots of coils and capacitors and variable adjustments in order to tweak it and make it just right. And there are 0.0 manual adjustments inside this exciter, none. It's all digital. It's all a computer. It's not a computer. It's all DSP, which is running formulas that create the most optimum signal possible, and audio specs like no other. A proven architecture that we use in the NVlt series is the same sort of architecture that we use in the NV series. There's a lot of redundancy built into the system, lots of intelligent features. You may have heard of some of these before, you may not. We've won a lot of awards for these features, and we'll go into them in more detail. Probably the biggest thing about the NVlt that is really cool these days, especially with the escalating costs of electrical power, is the efficiency of the transmitter. Whether you come at this from the perspective that says, how much money am I going to save in electrical running costs every month, or you come at this and say, how much cooler is my equipment going to operate and therefore have much longer life, or whether you come at this and say, you know, I'm concerned about the environment and I hate to see bad things happen to the environment. All of those are big wins for this kind of technology. 72% AC into RF out. Nobody else is doing that when you consider everything, even the exciter we're talking about. Everything is a part of this. And it's an exceptional value. The NVlt, when you build a series of transmitters in which you take off the table the need to be able to accommodate digital, you're able to optimize the design for other things. And in this case, we optimized for efficiency and we optimized for cost. And we took 20% out of the cost on average, less than the Nautil NV series. And frankly, that puts us in a range where we compete favorably with tube-type transmitters on price. So if you thought you couldn't afford a Nautil before, think again. In looking inside the NVlt, you have, this is the 20 kilowatt, just like the one we have sitting down in the test room at the moment. There are full access to all the boards and assemblies. It's the Nautil design, which, you know, Nautil has a long history and reputation for reliability. It's all assembled here in North America. Again, no potentiometers or trimmers, not just in the exciter, but in the modules and in the controller cards and all that. There's just nothing. It's all controlled via the AUI, which means you can do it from anywhere. Totally broadband, no adjustments, easily removable fans, and a washable air filter. So Mike, why don't you start taking us through some of these shots?
Right. So
on the left side?
Yeah, on the left side of the screen here, we've taken some pictures of the rear of an NVlt 10 kilowatt transmitter.
It's a lot cleaner than other transmitters.
It is. One of our focus points, obviously, on doing this was the efficiency, as you mentioned, but also to make it you know, easier for production and for customers to build and/or troubleshoot. So
sure.
The wiring was focused on to minimize kind of the point-to-point and the number of, you know, runs that were done in the transmitter. So at the back there on the lower portion is the power supply.
Right, which is also over here.
That's correct, to the lower right as well. So we're seeing where the power supplies connect to a power supply interface card, and the gray and white wires, the gray ones are the AC in,
right,
and the white would be the DC out.
Yep.
And if you can watch their path, they travel up the side of the transmitter and connect to another card at the top of the picture here, which is where the RF power modules interface card is, and that's the DC input to those modules.
Right.
So in our RF FM transmitters, the power control is usually done through varying the DC voltage on the RF amplifiers. And so those power supplies through a serial bus control can vary their output DC voltage.
A couple things to mention here, these three lights.
Right, so all of our transmitters are IEC 215 compliant, and that's an international safety standard, and one of the subparagraphs of that document says that you shall know when power is applied to the you know, the equipment under test. And so those are neon lights that do give indication that the AC power is present.
There's another really cool thing in here that I just love, and I guess it was Scott Marchand that came up with this, but there's this panel right here which is necessary to separate the parts of the cabinet which have high power AC in them and those that don't.
Right.
But you know, if you're trying to get down and wire this part, that panel's kind of in the way. So we made it really, or Scott made it really easy to pull the panel out just like that.
Scott's a big guy. He's 6'2", and he had trouble getting down there, and said, "Geez, it would be nice." And obviously, it's not a big difference in factory cost or the mechanics of the unit. So he made it so that it could replace it.
So you could just take this panel out very quickly, and then what you do is you have access like this. This is actually what this shot is showing, is that panel is actually removed.
Right.
So a little bit of the thought that went into this thing. So let's talk about the configurability of the transmitter.
So the power supplies that are operating this transmitter are effectively single-phase units. And so for single-phase operation, they're all running in parallel, and they have a very wide range of operation, 180 to 264 volts. And then we can orient them in three-phase fashion by putting an equal amount on each phase to get a three-phase version of the transmitter, which operates on the same range of voltage, or we can operate them as a 280 volt.
In other words, we can do them as delta or Y when we're in three-phase mode.
That's correct.
Okay. So
you can change that at a moment's notice.
Yeah.
The wires that exit from that terminal block shown in the small picture there just have to be repositioned, and they're all ferruled wires, so they're very easy to remove and reinsert. And so you can go from three-phase 208 to single-phase 208 to three-phase 380 in literally 5 minutes.
That's one of the tangible benefits to these sorts of supplies. Not only are they very, very efficient, and they provide a regulated output to the amplifiers over a broad range of AC inputs, but you can actually convert them in the field, whereas in the past you might have had to wait for a few weeks for a new transformer to arrive and then shovel it in place and pay for it. Now you can just simply do the changes yourself if you need to. So then we have the RF output flexibility.
RF output is configurable to any output size you may have available. So listed there, 7/8, 1 5/8, 3 1/8, they're all EIA, and then the 4 16 as well for.
Now we have a standard default, and anything else
that's right.
Small additional cost.
Yeah. So at the 10 kilowatt level, typically it's 1 5/8. At the higher powers, it tends to be 3 1/8. But that's a configurable item on the sales order form.
Okay. Automatic AC recovery.
Yeah, so that's been a long-standing, requirement and design criteria for our transmitters. They will, obviously go to 0 watts during a brownout or a loss of AC, but they will recover in the exact same mode that they were operating in a very, fast manner.
Yep.
Literally a couple seconds.
Very good. And then we'll talk more about the integrated exciter and what that provides as well. So this is the new module that we came up with.
Can we just go back for a second? Sure. So it operates on generators. So one of the things there, the power factor of this transmitter is near unity. So generators like that. And secondly, we do have software that does allow for a soft start under generator operation. So if you don't like the big step function from 0 to full power, we can gradually turn on the transmitter over several seconds or even minutes.
That's great. Yeah. Okay, so this new module, talk about why this new module is so cool.
So again, one of the focus design criteria for the transmitter was efficiency. Our VS2.5 had been using an LDMOS amplifier when it got released a couple of years ago, and so we looked at the advantages of that, and they included everything that's listed there. That first of all, it's 800 watts. That's kind of about double what the traditional VDMOS was available.
So now I've got less combiner losses, less splitter losses.
Exactly. And then the internal topography of the silicone is such that the source, if you're familiar with FET layouts, they have a drain, a source, and a gate tab. Right. The source is now on the bottom of the die.
So that's this one here.
Yeah, so it's now connected directly to the heat sink. So there's no more beryllium oxide. The thermal impedance is much lower, so you get a better thermal connection. And secondly, the inner connection capacitances are much lower, and that means that the gain of the device is higher. So we can remove actually a gain stage. There is no IPA in this transmitter. So you add all that together, less combiner stages, no IPA, higher efficiency amplifier, and we've come up with a module that's smaller, lighter, more efficient.
Excellent. Let's talk about the integrated exciter. This is one of my favorite things.
Right. So the exciter was an extension of the technology developed for the VS transmitter. We knew all those capabilities, inputs, the audio over IP, all those features were very well received by customers, and of course we wouldn't go backwards and offer a transmitter that didn't have all that capability. So
sure.
We definitely incorporated all those parts and pieces to that transmitter. But sorry, to the exciter. So any exciter needs to have RF power capability to drive those modules. Right. So we use the exact same RF amplifier, this LD MOS 800-watt device, and you can see that on the right-hand side there.
Yep, that's over here.
Right, so the exciter output off the low-level card comes out at a few hundred milliwatts, drives that two-stage PA, and then that drives the rest of the transmitter.
Perfect. Okay. One of the things that sometimes people remark when they see the exciter, they're used to exciters that have big fancy buttons and switches and knobs and all that stuff.
And that was kind of something that we started with the NV. We knew that the NV, because it was a ground-up design and had all this instrumentation, that the real, value of the transmitter was going to be had when you had the installed Nautel transmitter there. So we thought that, geez, we might as well incorporate it as a vertical element in the NV. Now, granted, it's come back to horizontal in the NVLite, but because it's got so much integration to the transmitter, we didn't see the need to put separate buttons and switches.
You couldn't just do away from everything. You've got two little LEDs over here at the corner. It says I'm okay and I've got power, right?
That's right, yeah.
Okay. So this is the back side. This is what you wire to when you're connecting up the transmitter. And so starting at the left, we have the RF monitor, the RF output, which then it goes to the modules and feeds the modules. Go ahead.
Yeah, I was going to say, so the next connection, this exciter, unlike our previous exciters, actually runs off 48 volts.
Yep.
For redundancy and for kind of ease of DC distribution and such, we thought it best to run the exciter off of 48 volts.
You have multiple power supplies in there that are providing 48 volts. And so in the old days, when you had an AC feed directly to the exciter, if the power supply in the exciter failed, you're off the air.
Right.
In this one, I can have a power supply fail, and I'm still on the air.
Right. You can have main standby power supplies for that operation part of the transmitter.
The exciter connects to the rest of the transmitter control system via a Ethernet connector.
Actually, the DB9 is for a lot of the comms and the control of the transmitter.
Right. This is the AUI input then, or
actually, for system control is when I want to run in a larger combined system.
Okay. Yep. All right.
The one that you're referring to is the next one over called Exciter Link.
Yep.
And that is an RJ45, but it's not Ethernet.
Okay.
It's connections between the backup exciter.
Yep.
And the main exciter.
Okay. Then we have remote I/O, which we can actually bring out to another board.
Right. So we've given a plethora of different connections, both status, control, and telemetry. And for ease, they are on DB25 connectors, but for ease, we've brought them up to a front panel circuit card as well.
Okay. And we have our primary AES EBU.
Correct.
And a pilot sample and a 10 megahertz in for SFN operation.
Correct.
And we have our over here, where do we have the one PPS shows up here, doesn't it?
The one PPS is on a DB9 connector.
And we have the inputs to the internal RDS and RBDS generators.
That's right.
As well as inputs from SCA or RDS external generators, if you so desire.
Right. If you've got a third-party generator, then it just is a VNC connection.
And here's a composite analog in, balanced or unbalanced.
Or unbalanced, right.
And then finally, here's our Ethernet connector for the AUI and two USB ports that we'll talk about what the value they have.
Exactly. So obviously, the back panel's got lots of connections.
Plenty of good stuff.
In a lot of cases, the size of the exciter is dictated by how many contact points.
Yeah, you notice over here that it's pretty empty, actually.
Yeah.
Okay, so the options that are available for the transmitter, there's not, frankly, a lot of them. Orban Inside, a fully integrated AUI version of the Orban 5500 series, is available for $1,200. It's a plug-in card, an optional card.
Right, that's a card that sits, actually piggybacks on top of the exciter card we saw in the previous picture.
Yep, right in here is where it plugs in.
And it can be installed in the field or it can be shipped, configured that way.
Okay. remote interface option is this card sitting over here.
Right, so that, as mentioned, so that's where the same connections are available in the back of the exciter, but that's brought to a convenient circuit card. And that's not only got those remote control, status, and telemetry, it also has switches on board.
And lamps.
And lamps. So
yep.
you can test your remote lines, or you can program them.
Well, it's an emergency control, too. If this display controller on the front of the transmitter and your AUI happen to stop working, you could go over to this and control the transmitter. Okay, so the UPS interface option. Now there's two, it's a little bit confusing potentially for these two cards. Why the two versions of card? As I understand it, you use this version if you have 220 volt UPS, and you use this version if you have 110 volt UPS. And in some parts of the world, 110 volt UPSs are less expensive, so it may actually be worth using the other card.
Correct.
Okay. We have redundant low voltage power supplies that run the exciters, the controller, and the fans.
Right. So that's 48 volts, and that goes to those items listed.
And we have dual hot standby FM exciters. Those are options as well.
Correct.
Okay. In air handling, tell me about this.
So the exhaust port on the transmitter is located on the roof.
Mm-hmm.
We sized it to be easy to connect external HVAC ducting to. So it's been made as either rectangle or square depending on the size of the transmitter.
In years past, I've seen lots of people's transmitters in which the air comes out the top, but they got all kinds of irregular shapes and strange things, and it makes it very difficult to connect a...
Right, so that was certainly one of our focus points on this design.
Okay, so we have both a top or bottom AC entrance.
Correct, so at the, we're looking at a shot of the roof of the transmitter there, and on the four corners you see some square
plates,
aluminum plates, so they're covering up connection points at the customer. You simply take off 4 screws and you've got a standard conduit-sized hole there.
Right. And then there's ducting inside.
Yeah, and we'll see a picture of that later on in the presentation. But we took feedback from customers as far as the internal cable routing in our transmitter.
Making it easy and make it beautiful when you're done. I mean,
it certainly
wires aren't hanging all over the inside of your transmitter.
Exactly.
This is our RF output, which is in the rear on the top of the transmitter, very easy to get to. Right?
Yep.
All right. Fire away.
Okay, so in the development group that I'm head of, we've got 3 teams, one for AM, one for FM, one for navigational. We are in constant contact daily with our sales team, the customer service representatives, people in production, and of course we're getting feedback all the time. We track every case that we hear about. And so when it came time to develop this new family of NVlt transmitters, we reviewed all the cases that had been logged for previous transmitters and the customers' experiences that we had, and we put that into our design criteria for the NVlt.
And all of that information comes from not only what the sales guys tell you, but what you've heard yourself or seen yourself when you've been out to site.
Sure.
Or what the customer service team.
Yeah, I visit a lot of sites. I attend NAB every year. I talk to the end users, and so some of the things that AC entrance, safety, and ease of installation of the wires. So we've got finger-safe terminal blocks here for the AC interconnect. The wires on the high-power NVlt transmitters now are directly. There's no bend radius required on the wiring. It comes directly into it. So that was one of the feedback points. On the right-hand side,
the duct we're talking about.
we're seeing the upper right-hand corner of the rear of the transmitter, and that's essentially a conduit that runs down the inside skin of the transmitter. So you can put in your Cat5, your audio cable, coax, whatever whatever is required.
Okay.
That's just another shot of the lower AC portion of the transmitter. We're seeing that we pre-install ferrite on the AC line to help with maintaining balance on the lines and keeping RF out of the AC.
And improving lightning protection.
Protection as well, correct.
Yeah, and then this is the remote control card.
That's the remote control card with the buttons we spoke of that can be programmed for auxiliary control.
Okay.
The battery on the exciter, it's only used to keep the real-time clock working. So if it was to, fade, then
and you got to reset your clock.
you got to reset your clock.
Unless you've got the new NTP client running, in which it'll set itself.
And that was, yeah, that's a good point. But again, a feedback point from some of our customers: why do I have to take off so many screws to get at the battery? So we did something about it. We mounted the battery on an external wall of the exciter, so you can now just extract that.
Somewhere out there in webinar land, somebody's going, woohoo, they listened to me.
Yeah, exactly.
Great.
And then finally, the last picture there is the UPS unit, which is or option. It's simply a box that allows the AC routing from the output of the UPS to the internal power supplies, and
just the exciter and controller. So that's all that's running on the UPS.
And that can be installed in the field or again.
And the big value of that is it keeps things. You don't have to start up a little slower if you don't have. It
keeps the AUI running all the time, and it does improve the recovery time of the transmitter.
Right. Okay. Again, looking at that same information, this one.
So this is a 20 kilowatt, again showing that the exhaust ducting is in fact rectangular, easy to connect to, and we've got leveling feet in the corners of the high-power transmitters, to help.
Because of the larger footprint of these.
Larger footprint, and because all the connections, all the modules and power supplies are blind mate, it helps to have a level transmitter to allow that mechanics to work properly.
Sure. Okay.
Intelligent protection and monitoring. So we've mentioned the AUI, the remote control board that can be put on there. Commonality. The exciter RF amplifier, as I mentioned, is using the exact same assembly as the PA. So in a pinch,
if you stock a spare RF module PA, you can plug it into the exciter.
Yeah,
that's cool.
Exactly. The low voltage power supply in this case is the exact same power supply as the rest of the transmitters. You can see that picture of that NVlt 20. All of those modules down the bottom of the rack.
Those are the green handles.
Yeah. So there's the ones on the extreme left and right are for the power modules, and the ones that are in the middle are for the low voltage power supplies.
So just to stress that a little bit, all these supplies are exactly the same. You can take one out of one slot, put it in another, have one spare one on the shelf if you want to, or all that. They're just, there are no other power supplies on the transmitter.
And again, this was a feedback point of talking with customers.
Great. Okay.
Only one fan used throughout the entire transmitter. We've been guilty sometimes of having more than one type of fan. The exciter, the reject loads, the power modules, all the same fan.
Super. And these are ball bearing fans with an 11-year life.
Correct.
Yep.
Very, very, very long MTBF.
And there's even common PC cards with the NV and VS.
That's right.
Not all of them, but some of them.
No, the exciter card is actually the same card that's been used in the VS.
Okay. Now this is having to do with the new software version. We've got a totally new webinar coming up in the future talking about software updates. But this is some of the stuff that's already available in the NVLite.
Right. So the NVLite was leading the charge for the latest and greatest transmitter software. We've brought the other products up to meet it. But as part of its feature set, it's got all these.
So it accommodates the Orban Inside option, has all the IP audio function, USB backup, push radio. The scheduler is really cool. We'll get to that. NTP client built in, so the clock is set automatically.
Just so people that don't know, that's network time protocol, so you can sync your real-time clock on the transmitter to your network.
Multiplex power limiter, something's needed in Europe particularly.
Right, that kind of monitors the overall modulation depth of the transmitter over time and manages that.
Left right limiter. Right. Okay, push radio, Nautel phone home. We'll talk about these in a little bit more detail. Here's one, secure email. Explain that one, Mike.
Okay, so if the transmitter does not have an email server in it, it needs to talk to an email server.
Sure.
So when it has an alarm and you've set up the transmitter accordingly to notify you of that, it can negotiate with an external, say a Gmail or a Hotmail account, and send the end user.
So in the past, we had to use one that was an open SNMP, is that right? SNMP? SMTP. Sorry. SMTP.
Yeah.
And now we can use one that requires passwords like Gmail.
Yeah. Exactly.
Okay. SNMP.
SNMP, Smart Network Maintenance Protocol, is another Ethernet protocol. We've added traps. So Traps,
again, something requested by our customers.
Exactly. So traps are a very useful tool. Again, almost like the email, it will send you an unsolicited message when an issue in the transmitter has been detected.
Great. Non-volatile meters, delayed TREA.
The meters on the front of the GUI used to go away when you lost power.
Yep.
That was a big...
or even logged on what came in again.
Right.
And now they don't.
And now they don't. They stay there.
Very cool.
Yep.
Again, I hear a muffled yay from people on the webinar. Low audio thresholds with adjustable timeout. We'll see this as we move on here. So
installing an NVlt is probably the simplest transmitter that Nautel has ever.
We've heard people installing these things in a half hour or less. It's crazy stuff.
From 0 to RF out the antenna in very very short order of time, and all because of some of these features we put in there.
It couldn't be much easier.
Yeah.
Okay, and then one of the things it does is it automatically, the transmitter comes up and asks you what the frequency should be and the power level should be and the audio selection should be, and it won't make power until you tell it.
Right, and so this, for larger groups that are buying multiple units, if they need to change their location or, it just makes it quick to get on the air.
You bet. Okay, live wire is part of the transmitter. This is the standard among a lot of companies have tied into this for digital transmission of audio over Ethernet, particularly. Right. And so these transmitters, the Nautel transmitters, are the first live wire enabled transmitters in the world, and that's pretty cool. We're proud of our association with the good folks at TELUS Omnia Axia with that. Shoutcast, Icecast, the ability for the transmitter to know that you're streaming, and if the main STL were to go down, the transmitter can be instructed to automatically switch over to your web stream and pull up that web stream and put it on the air. Very, very powerful. It also could be a nearly fully STL if you have a high reliability IP path.
Exactly. Yeah.
The internal USB player, the ability for the transmitter to actually have at its access plugged into the USB port, either a memory stick or a 2 terabyte hard drive with could be hundreds of MP3 or WAV files, and then create a playlist or multiple playlists, and then play those out like a mini automation. Now, it's not a full automation. It doesn't have some of the features that an automation has. Doesn't segue, but it is capable of doing a playlist inside the transmitter. And these last few things explain the reason why the Orban Inside option is absolutely necessary. Because the Orban, there's no other
audio
there's no other place to put it.
Yeah.
If you're going to be able to switch from AES EBU to left and right analog to streamed audio to live wire to playing USB files, you've got to have the audio processor inside the box.
Exactly.
And this is not only a much less expensive option, but you get to control it through the same AUI from wherever you are, and it has the same look and feel as the Orban 5500 series. And so we're very proud of our association with the good folks of Orban. Presets. This has been a feature in Nautel transmitters for a very, very long time.
Right, so presets have all essentially the user-controlled variables, frequency, power level, the audio port that you're going to want to use, RDS and SCA configurations. So, and you can save, like it says there, 50 plus presets, and call them up for whatever operating mode or time of day or whatever the time calls for.
Push radio is taking that concept of USB audio and saying, in some situations, in some parts of the world, in some categories of stations, having the audio locally stored and playing it out of playlists makes a lot of sense. Maybe they're using satellite today or something like that. This way, the content can be pushed out and stored on those hard drives through the internet, and it can be actually controlled by an ENCO system. So you could have 100 transmitters out there and be sending the audio out to each of these, make sure that the content is available in every transmitter, and then creating playlists for all of those. So it adds localism because you don't have to have the same weather forecast at each site, which you might have to do if you're using satellite. Improves reliability, doesn't suffer from sun fade, and it reduces distribution costs. And this is really the big one, because in a lot of these kinds of networks, the satellite distribution cost is the largest operating cost they have. So push radio is part of this this transmitter, and it has tremendous flexibility and functionality in many parts of the world. Phone home, an idea that our customer service manager, Kevin Rogers, had, and it's won a Pickett Award. It is the whole concept of taking the customer service team and making them proactive. It gives the customer service team access, if you choose, if you flip the switch and say, I want to do this, it gives the customer service team the ability to compile the data of all the transmitters that are out there that are being part of this, understand what's going on. If you call up and say, I have a problem with my transmitter, we say, yes, I know, I think it's this, because we already have the readings and on the complete detail. Your transmitter sent it to us, and it's residing on our server. It also allows us to take a look at the whole big picture of, are we having a problem with this batch of fans,
right,
for instance?
And if if the customer service and the engineering people can have access to that information, it helps us to troubleshoot all that much more efficiently.
Natal has for a long time been thought of as the leader in customer service and supporting our customers. We've never discontinued support in 44 years for any product. This is another step where we're advancing the state-of-the-art into proactive customer service. Let's talk about some of the features in terms of redundancy in the transmitter. Obviously, a transmitter in a radio station is a mission-dependent device. You cannot, the radio station, most stations don't have main and alternate transmitters. So you've got to have ways to keep the transmitter on the air at all costs.
Right. So, I mean, if you look at the topology of any solid-state transmitter, the RF amplifiers are obviously the heart of, the energy being pumped out to the antenna. So the NVlt has a number of those modules. They're 2.5 kilowatt modules in parallel in a hybrid combined fashion. They are hot pluggable, which means you can disable the module and pull it out without turning off the transmitter. You don't interrupt the power.
Same with the power supplies.
Same with the power supplies. There's 2 power supplies for each RF module, and they're in a hot pluggable arrangement as well. And we've mentioned they're all the same assembly. They can be swapped back and forth if for whatever reason you may have.
Sure.
The cooling fans, there isn't one central blower that cools this transmitter. It's done with 6 small fans inside each power module, and then each fan has its own fan, or each power supply has its own fan as well.
And each one of those fans has a tachometer, which is sending back the exact RPM to the AUI, and you can monitor that.
Every fan is monitored in that transmitter.
Yep.
One of the design issues when you start looking at high-power transmitters is power under failure mode. And we thought this very important. So you need to size the reject loads appropriately, and so we think we've done a good job of that, and we can still achieve up to 90% with under.
And the interesting thing is, this is the NV10 light.
Yes.
If this was the NV40 light, these numbers over here would be higher.
Even better. That's correct. Here.
Okay. And then there's the standard type of reliability redundancy that's built into a solid-state transmitter.
Right. So the amplifiers and the power supplies, as we mentioned. The control monitoring can be done via the remote board, the dual exciter capability, and the dual low-voltage power supply option.
Great. Yeah. This is talking about the efficiency. This is really important.
Right. So 72%, as you mentioned, kind of that's probably the highest in the industry. If you did the number crunching just at 10 kilowatts.
Well, this is 44.
Oh, sorry, at 44.
$8,000 a year.
Yeah, it's huge. So 72% is significantly higher.
And that's relative to an NV transmitter.
Right.
If you've got an older type of transmitter that's long in the tooth, probably your numbers are even better than that. Right. So that's right.
Yeah.
This is an important number, although people may not understand what it means. It means the temperature rise across the transmitter, right?
Right, so there's a delta T. The input air is obviously at the ambient, which is typically in the low 70s, and then there's a rise as it crosses the heat sinks and extracts the heat from the transmitter. So 46 degrees Fahrenheit. Less than what it would have been in the previous designs.
Sure. So it's half the rise is what we're saying here. Okay, and the auto variable fan speed means that the thing is a lot quieter.
Right. So one of our feedback points from our customers was that these large transmitter halls, the ambient noise was a critical part of their selection process. So we made the fans adjustable on the DC voltage that operates them. And so they're looking at temperature, and they're trying to keep the slowest and quietest RPMs for that operating point.
And the switching power supplies are miraculous. They're 95% efficient AC to RF, yep, or AC to DC.
AC to DC.
Yep.
Very, very high efficient. The 2,700 watts being operated at closer to 2,000 watts. Mm-hmm. So they're conservatively rated there. They've got a lot of internal measurement capabilities, including total current, voltage, temperature. It's a wonderful.
And they all communicate with the AUI and provide that information to you.
They're on a serial bus and passing along their information to the user interface.
Great. So now what we're going to do is talk about the AUI, but we're going to do more than that. We're going to try to switch over to the AUI and let you see that in operation. So I'm going to show, I believe I've got it now. Actually, we'll do it this way and I can make sure of it. So now I should be showing you the AUI of a 20 kilowatt transmitter sitting downstairs in our laboratory. You can see the banner at the top, which has all the information which is there on every screen of the AUI. Allows you to see the output power of the transmitter, its preset point, what reflected power we're getting back from, in this case, a dummy load. The mode we're operating in, obviously, it's analog FM. We only have one exciter in this transmitter, and it's the A exciter. And our FM modulation is sitting pretty close to 100% on peaks, as you can see that there. Here's a spectrum analyzer, a real spectrum analyzer. Yep. If I full screen this, I can actually put markers on it and see exactly what the levels are and how clean it is and that sort of thing.
And I can probe different points within the signal chain, which is really cool.
This is another fun thing I can do here. I can bring up this one, and I can come over here to this and look at multiplex and hit OK, and that switches it. Now I'm looking at the baseband composite,
right,
which means that this is 0 to 100 kilohertz and 100 dB top to bottom. So there's my L plus R, my 19 kilohertz pilot, my L minus R.
Right.
Now, just for grins, let's have some fun here. So let's go over here to this preset, and we're going to come in here to this preset. We're going to turn on a multiplex SCA, and we're going to save that. We're going to change the status of the current transmitter. We're also going to turn on RDS, and we're going to put that at a 5% injection level. And I believe that ought to work. So I'll hit save here and hit OK. And now I'm going to go back here, and I'm going to take this back up to full screen. And now you can see that I'm seeing the RDS right there at 57 kilohertz. So that's happening. Now let's see. Let's minimize that back to where it came from. We're also seeing the display of the audio processor that's inside, looking at the EQ response here, and we're looking at Localism, which is a real-time audio display showing what's coming into the transmitter. And you may be saying, where's this audio coming from? Well, in actual fact, we're actually bringing a stream in from a local radio station that is streaming to the web called CoveFM, and we're bringing that stream in through Shoutcast and putting it right on the air into our dummy load. So
I will mention, just to go back to the EQ impulse response,
right,
that's actually an RF EQ impulse response. So we have the ability to equalize root delay and or frequency response issues that may be associated with downstream components,
like
combiners or
something like that. Yep.
So that's something that's really cool about that.
And that's very valuable. There's a lot of consultants in the industry that keep that in their bag of tricks because they can make the transmitter sounds ever so much better in the client station. Yep. Okay, now I should mention that there's a lot of tools that you can bring up and throw in these spots. So here's some of the other tools that we can take a look at. I think this one was on this issue. So now here's our meters that we talked about, and the Save Meters button. So this one has been saved, and this one was done for NAB. So those are, every time we come up, it will automatically bring up that list, and we could have multiple presets.
And let's just quickly here look at some of these meters. So the DC to RF efficiency, so that's 78.4. So the power supply is 95, 96%. So you're looking at probably 73% AC to RF. That's impressive.
So here is a menu of things we can do. Just want to hit a few of the high points here. So here's the playlist editor. This is where we're currently bringing in the CoveFM stream. So that's the CoveFM stream. And over here, if I had a USB plugged in with files on it, I could create a playlist and multiple playlists and create those all and save them, and then they could be run as a part of the presets. The other one that's really cool, oh, by the way, we'll go back to here for a second if I can. Yeah. So you see, because it's a straight line, it's more or less mono information coming from COVID at the moment. Now we just had some stereo information. So, okay, so now let's come over here and look at the, oh, not that one. Let's come over here and look at the scheduler. So this is a rule-based scheduler. This allows us to create a rule that says, okay, every Wednesday at 10 p.m. go to low power, or switch to the satellite at this time, or switch to a playlist, a local playlist. Or, for instance, you could be bringing audio from a satellite in on normal broadcasts, and then you have breakaways for IDs or weather forecasts or things like that, that it could play various playlists. It's up to your creativity to make this thing happen, and it's virtually unlimited in terms of its abilities and capabilities. As a rule-based scheduler, you can make it do anything you want, and everything that you do just shows up on these calendars for years in advance, and it makes it very, very easy. Now, again, you couldn't do any of this and have it really work right. Is NTP in here?
NTP
is, let's see. Yes, it is.
Yeah.
Yay. So here's where you bring in your NTP. So let's enable NTP and hit apply. And it's going to use this pool of NTP clients. And it's going to, so now it's set up its NTP already. And we can set up the time. We can set up the time zone. All of this information can be set up this way. So there's a lot of flexibility in the system here. Here's where you go set up the Orban inside. You've got all the same kinds of features that you would normally have in an Orban. You can load presets in all the normal presets. You can create your own presets just like you would have with the optional Orban inside. So those are some of the functions. I'm trying to think if I've missed anything of high level. Let's go through the presets and just show you what's available here. Here's where you set up your frequency, your power level, your audio source, the audio sensitivity, whether you're going to use a 15 kilohertz low pass or any preemphasis. We should probably throw some preemphasis on here, right? 75 microseconds, given where we are at the moment. So now we're 75 microseconds. Here, come over here. This is one of my favorite menus. Here's where I set up my pilot level. If I'm going to use a SFM or synchronous frequency network, I would configure this to be on, and then I would set up my pilot sync phase, so it would sync to the 1 PPS. I could configure an audio delay if I needed to get that SFM timed appropriately. Mod loss timeout is a huge, huge feature. It says, what happens if my modulation goes off? What do you want me to do? Well, I can switch to another preset. That other preset could be, for instance, an internal playlist. It could be a different STL, a backup STL. It could be a stream from your station, whatever. And you configure what that is in terms of the timeout, minutes, seconds, and then the threshold. Is it, what if it's 5% modulation for 5 minutes? Well, it will switch if you set your threshold for 10%. We've got an internal hard limiter, an internal AGC limiter, and a 2-slope limiter. We also have the ability to turn on and off the Orban processor, configure the Orban preset as part of another preset. This is really key because suppose I'm using one of these transmitters in an N+1 configuration. I can have the transmitter, the +1 transmitter reconfigure itself for frequency, audio input, but also I could configure all the RDS settings, the SCA settings, and the Orban preset for the frequency that thing is shifting to. So when we tell that transmitter come up on this frequency, it does it, and all of the rest of it switches with it. Yeah. So those are very, very key features that are parts of this transmitter, and more or less standard in the transmitter. Logging is another really, really cool thing. So in this transmitter, we have a ton of logging that is built in. And those are the major functions in the transmitter. We can reset any errors or whatever. We can. Oh, one other thing I want to show. Come over here to this. Let's close that meter. Let's open up more meters, and I want to show you how this looks. So this is currently showing you all the readings in this 20 kilowatt transmitter of all the things we're monitoring in every module. So you can see all of the currents, all the voltages, the heat sink temperatures, the RF drive powers, the fan speeds, bias voltages. Everything is being displayed on one easy screen, and I can be doing this from anywhere. Right. That's a very, very powerful thing. And again, this is a standard part of the Nautel transmitters. So let's go back to here and switch over to this one. And meanwhile, I'll switch over to this one and finish up here. So all of these transmitters come equipped with a 4-year warranty, and that's a standard feature in the new Nautel FM transmitters and AM transmitters. And to summarize the MVlt, fewer trips to the transmitting site, reduced engineering effort, built-in instrumentation. I was talking to somebody at the NAB show who told me that our transmitters are boring, Mike. He says he installed one a few years ago, and he's never been to the site to look at it since.
I've heard that comment myself.
Do change the air filters, folks. It's a good idea. Unmatched control, highest solid-state efficiency, the option of the Orban 5500 series, and it's an exceptional value, much less expensive than the other
on
series.
The engineer in me.
Yes.
I was going to point out, there's a slide earlier that said 8 degrees C.
Yep.
It was 46F. That's not the right
I didn't think so.
No, I mean 8 degrees C is about 15F.
Right.
So this
Fair enough. Okay. So now is the fun part where we get to answer your questions, if there are any here, and I will go down and take a peek. And let's see here. Okay. There are several questions here. Our audio is too low. I'm sorry about that. It was the first question, and I just now looked at it, and I'm sorry about that. It says, how well does the efficiency track across the power range of a given model?
The NVlt actually is excellent tracking. Some of our previous amplifiers would fall off maybe 10% at half power, but this stays very close to that efficiency to probably less than half power. It might be down maybe 5 points at half power.
Yeah.
Very,
Another person corrected an error that I made. He says that the RF output is in the front of the
and I was going to say that.
My mistake, folks. Sorry about that. I was turned around while I was looking at it.
That's the back of the transmitter picture.
This is somebody's asking if this is a webinar for radio or television. This is a radio webinar. This is FM transmitters. We do have a television webinar coming up. Watch this space. It's coming up in just a couple of weeks. Is the LVPS, low voltage power supply, in a module or just a board?
It's a removable module.
It's a removable power supply that's the same as all the other
same power supply. It's a 48-volt power supply, 2700-watt power supply that's used for all the applications in the transmitter.
Okay. And it says this gentleman missed part of it, and he said he missed the first few minutes. Branded as a light, it would indicate that it's less than a plain NV, but it's not. What am I missing in the name light? Well, the main thing is that it doesn't do digital.
It doesn't do digital,
but you're right.
Yeah, well, one of the, when we first started on this path, we wanted efficiency and cost reduction, and part of that cost reduction was achieved by removing the front screen on the transmitter.
Yep, that's right too. Yep. Okay, we don't have a 17-inch color screen. Another gentleman says, these look great, can't wait to get one. Is there any thought to having LPFM transmitters in the 30 to 150 watt series like the BS transmitters? Thank you for the comment. Haven't done anything on that yet. May very well. Appreciate the comment. And will there be an iPhone or iPad app? I will tell you that there's work going on around here, that we recognize that Flash is something that isn't so commonly available outside of PCs, and we hope to be able to introduce something like that in the near future. We do hear that comment. Thank you. And I believe we've exhausted the questions, so back to here. We do have a number of ways that you can keep up to date with Nautel information. The Nautel Waves newsletter is a wonderful way of doing that. It's issued every few months. And just click on this link at nautel.com/newsletter. We also have this webinar and all the rest of the ones that we've done previously archived and online, and you can watch them at your leisure at nautelcom.webinars. We also have a YouTube page. Search for Nautel Limited. and a Nautel store where you can buy spare parts and everything 24 hours a day, 7 days a week. We also have service available through our live help system online. And so we try to be very, very accessible here at Nautel, and we listen to our customers. And the last thing I would have to say is, with all these NVlights we've been talking about, we've got one here with your name on it, and we'd be ever so proud to have the opportunity to work with you as well. So for Mike Woods, I'm Chuck Kelly. Thank you very much for being with us today, and have a good one. Bye-bye.